Welcome, ladies and gentlemen, to this Mediterranean Passivhaus conference. My name is Wolfgang Feist, and I am the scientific director of the Passivhaus Institute. What you see on the first slide are lots of already built passive houses all around the globe. The basic principle for the passive house is to use energy efficiency. That means that we provide the services, for example, warm keeping of the coffee, by better insulation and not by introducing a lot of additional energy. The same works with the passive house. So if you look at a contemporary average building, the demand for heating energy is really high. With a passive house, we improve the insulation to the outside, we use better windows, passive solar energy, and use a heat recovery ventilation, so we can reduce the overall demand for heating energy by more than a factor 10. This is working very well, so it gives a very comfortable and user-friendly building. All the surfaces of the envelope are warm during winter and will be cooler during summer. The heating load in existing buildings is in the range of some 100 watts per square meter, and the cooling loads are in the range of some 50 watts per square meter. With a passive house, all this is reduced to just 10 watts per square meter. Now, how is that working? This is shown in this section of a typical multifamily passive house, which has been built by my friend Professor Enver Schneider in the year 2000. What you see there is a very well-insulated building envelope. So that keeps the heat or keeps the coolness inside of the building. It has to be free of thermal bridging, and we use properly insulated passive house windows. There is an airtight building envelope, and the fresh air is supplied by a ventilation with heat recovery systems. Now, the passive house is not only a very energy efficient building, it's also very cost efficient. It means that in the Mediterranean climate, so this is now a place in the southern part of the Mediterranean, it's a very less heating site. Here you see that if you reduce the energy demand for heating, you will have to invest a little bit more investment into the insulation, into the better windows, into the heat recovery ventilation system. So that grows quite up to some values, but on the other side, you will reduce your heating bill. So the costs which you spend for heating will be reduced step by step. Now, how much money will you save? Well, that's depending on the price of energy. So if you have a very low price of energy, which is 6 cents per kilowatt hour, we will still have the passive house at the minimum of this cost curve because the passive house has a simplified supply system inside of the building. But the cost for energy won't be that small as we see here. It's already now in a range of 8 cents per kilowatt hour. And you see, if we go to 8 cents per kilowatt hour, that now there are already quite high total costs for the life cycle of the building if you build it not to a very energy efficient standard. Now, if we go to the more reliable value of some 10 cents per kilowatt hour for the energy we have to buy for keeping the building warm, you see that there is a much steeper curve here, and you see that the passive house and the range of a passive house then is by no doubt the most economically efficient construction. So even if the energy prices range quite a lot between 6 cents or 8 cents or 10 cents per kilowatt hour, it doesn't matter. You will have very low total costs with the passive house. So the passive house is the most economic energy standard. Well, it's clear that it is very economic to use a passive house for the system because the total equipment you need for heating the building is very much simplified compared to what is normally be done. So in a typical passive house, in the living room, 10 candles would be enough to heat the whole building, and that is independent of the climate the passive house is built in. Now let's look a little bit on the examples. How would a passive house look in the South Mediterranean area? I have looked into that for Athens, and I just show you here a first case. That is, we use a proper insulation of the roof. It can easily be shown that independent of climate, the insulation of the roof should be in the range of 25 centimeters, because that is the minimum cost you can achieve with any construction. Now, in this case, we just use exhaust fan ventilation, so no heat recovery in this case. And we have a typical passive house, high energy gain glazing, high G glazing, which has a solar performance factor of 62%. So that means that you get very good solar energy during the winter. But it also will give you a lot of solar input during the summer, and that is the solar load. So now we need some movable shutters, and we need a sunscreen in order to keep the building cool during the summer. Now in this case, heating is not a big issue, so it would be enough to insulate the external wall of such a building by some 4 centimeters of external insulation, which gives you a U value of 0.63, which is far higher than the U value you could easily build with affordable costs. Now, both the heating and the cooling energy is in the range of 15 kilowatt hours per square meter and year. So yes, this is a possible example of a passive house in the area of Athens. Now let's look if we go a step further and say we use a sun protection glazing. Now this is a glazing with a very low G value. It just gives you enough daylighting inside of the building, so you won't need extra artificial lighting during times where you have enough daylight on the outside. Now we can reduce the sunscreen, and we will still be in a cooling range of 15 kilowatt hours per square meter and year, so it's still working as a passive house. But during winter now, the energy demand will be higher. So in order to reduce that demand, we would have to use a better insulation. In this case, it's an insulation of 8 centimeters, a U value of 0.37. That is still a U value which is much bigger than the one which would be economically feasible in Athens. That's in the range of 0.25 watts per square meter Kelvin. And it's still just an exhaust fan ventilation. So this is another case of a passive house in Athens, case number 2, and that might be a quite clever case to build passive houses like this in the region near Athens. Now let's look at another case, that is if we use the heat and humidity recovery system. That will allow for reducing the heating load and reducing the cooling load, because with the humidity recovery we can have some of the humidity on the outside during humid periods in the summer. We can keep it on the outside. So that now gives us the possibility to reduce the amount of insulation needed again. So that is another possibility to just build passive houses in Athens. So you have a lot of different modifications which you can use in order to build a passive house in such an area. Now, a very big advantage of a passive house is that we know that it's working. It's long-term tried and tested. This slide shows the results of the energy consumption. In this case, the red bars are for the heating during the last 20 years in the first existing passive house in Darmstadt-Kranichstein. And what you see here is that the overall consumption for energy, not only heating, also for domestic hot water and for the ventilation system and for all the other uses of energy, are reduced by more than a factor 10. So it's a long-term, stable, nearly zero energy building. This has not only been confirmed for the first passive house construction, but it has also been confirmed for lots of passive house developments which have been built in several cities all around Germany, in Wiesbaden, in Stuttgart, in Hanover. What we see here is the average consumption for heating in all these more than 100 dwellings, which are down to some 13 kilowatt hours per square meter and year, and thus 80% less than the average consumption in an average new construction, and more than 90% less than the consumption in existing buildings. So there is no performance gap in passive houses. So there's a lot of discussion about the so-called performance gap, and the performance gap you can easily get if you have a system which is not properly designed in a technological way, so you won't get the savings you wanted to have. But in the passive house, we can really show that we get the savings which have been calculated for. Now it's very easy to design passive houses. You can use the design tools you are used to use as an architect. So the first thing you do, you set up your SketchUp, and together with a program we call Design PH, we use now your SketchUp tool to draw your building as you used to. So you get a first sketch of your design building. This, for example, is the design of the first passive house built in Darmstadt-Kranichstein. Now, you can just let the Design PH program automatically identify the external envelope of the building, including the roof, the walls, and the windows. And now you can import the data into the PHPP worksheet. The PHPP, that is the Passive House Design Package. And the Passive House Design Package, you get all the results for the consumption of a building. In this type, it is 14 kilowatt hours per square meter and year. You get also the data for the cooling. You get also the data for possible overheating, and you can design all your technical systems using this tool. Now, another advantage of the Passive House standard is that it's a very well-defined standard. So there is a quality control available. There is a quality control during the design and the construction, which leads to the certified passive house. There are quality controls for the components. So a passive house component is a component which can guarantee you that when you use these components, you can trust the values and you get the results with the PHPP which you really need for your energy balance. And there is quality assurance for those who are working with the passive house. You get education and certification of passive house designers, of advisors, and of crafts persons. Now, the cost-optimal U values for passive houses will, of course, be different all around Europe. What we see here is that in the far north, you need a quite well-insulated building in the range of U values of 0.1 watts per square meter Kelvin, which is corresponding to some 40 centimeters of insulation. And the further we go to the west and to the south, the less thick the insulation will have to be. So let's look at the southern parts of Portugal and Spain. So you'll see we are in a range of 0.3 and even up to 0.4 watts per square meter Kelvin. So all the components which you need to build such well-insulated external building envelopes are available on the market, and there are lots of certified products which you can use. Also, passive houses can be built for different tasks. School buildings have been built, social houses have been built. This is a passive house office building which has been built in Vienna, a passive house kindergarten, and even swimming halls. An example from my new hometown in Innsbruck, there is a passive house development with more than 345 buildings which have been built by the social housing company Neue Heimat in Innsbruck. And the experience with these buildings were so good that the next step they did, the next development, that was the Olympic Center 3, was another 444 dwellings, which also have been built to Passive House standard. And this company decided to build only passive houses in the future. Another frontrunner is the city of Brussels. In Brussels, the Passive House standard will be introduced by a legal approach from the next year. And they have already a experience of several thousands of square meters development, including the energy ministry in Brussels, which has been built to Passive House standard. This is an example from Korea. In Korea, the architect Gernot Valentin built one of the very first Passive House seminar and apartment buildings, which has a heating and a cooling in this climate, and both are very, very efficient compared to what has been done in Korea in average new construction. And that's another example from the United States. That's in Philadelphia. I am very proud of that building because that has been built in an affordable homes program. So this is not an expensive development. It's for those who don't earn enough. It's for those who can't afford expensive buildings. So it was built in a very inexpensive way. And it also has a very low cost for heating and cooling. Another example is these passive house developments of the city of Heidelberg. City of Heidelberg has built a whole part of the new city completely in passive house standard, including research buildings, office buildings, hotels, dwellings, students' homes, and a lot of other constructions. There are, of course, regional solutions for building passive houses, and there have been passive houses built in the Mediterranean area. So this is an example from Spain, one-family homes in Weira. These are examples from Italy, another example from Italy, and the Marconi buildings near to Pisa in Italy, they have been retrofitted to be passive houses with that retrofit. In a passive house, we can use the renewable energy to a very high extent for supplying the rest of the energy you need. It's preferably wind energy and photovoltaic electricity, which can be produced and can be used in such a passive house for the heating, cooling, and the other demands we have in that building. Part of it can be used direct via the grid for supply. Another part will have to be stored in an intermediate storage that is for, say, a day or a few days. Another part will have to be stored in a seasonal storage, which is working with gases, combustible gases, which can be stored in tanks and can be reintroduced to the grid by combined cycle power plants. So this concept is a concept which can be used with the new passive house classes, which will be introduced in the future, and Benjamin Crick will talk about these passive house classes a little bit more in detail in some of the upcoming presentations. So the new classes will be the classic passive house, which has an energy demand of 85 kilowatt hours per square meter and year, will be the Passive House Plus with a reduced renewable energy demand of 70 kilowatt hours per square meter and year, which is additionally producing some 60 kilowatt hours per square meter ground area and year and feeding that to the grid. And there is the Passive House Premium, which produces much more renewable energy from renewable sources at the building and nearby, and is using only 55 kilowatt hours of renewable primary energy for keeping the building comfortable during summer and winter. This is already an example of such a Passivhaus Plus building, which has been constructed by Neue Heimat in Tyrol, the one I already told you about, that we are building only passive houses. Well, you see, it's a typical new constructed building, and you have to have a close look to see where the specialities are. And yes, you see here, there are the photovoltaic collectors which collect more solar energy than is needed all over the year by this building. Now, passive houses have been built all across the globe. And what you see here are the locations of some examples of already built passive houses. So what you see here is it's all around the European Union. A lot of buildings being built in Canada and the United States of America, and also in Mexico. In South America, we have examples in Argentina and in Chile. Even in Antarctica, there is a first built passive house. And we have a lot of new examples now coming up in the eastern part of Asia, in China and in Japan and in Korea. So the passive house is an international standard which can be used within all types of climate and especially is very attractive for the Mediterranean area. At the end of my lecture, I want to invite you to the International Passive House Conference. That one will take place, it's already the 19th International Conference. It will take place in Leipzig next year between 17th and 18th of April 2015. It will be combined with an exhibition and with a large framework program. So be prepared to come to that place, which is well known as one of the nice centers for business in the Republic of Germany. Thank you very much for your attention, and I wish your conference a very good success.